Okay, so the last topic of this unit, of Unit 3, so we're coming up on a test, right? We got probably, go ahead and click them all the way closed. We've got, I'll wrap this up on Tuesday. I'll give you guys a review assignment on Tuesday. We will review either Thursday for a test on Friday or next Friday for a test the following Monday. Okay, but we want to get it in soon. Test Friday. Well, we'll see. I mean, if we can, I'd prefer that. But I want to make sure everybody has adequate time to do these assignments and the reviews. And I want to give you maybe an extra day to get things caught up prior to the test also. Okay, so today, the last topic is transformations of functions, and we're going to do, so on the assignment that I put up, the new assignment, do not go past, I think you can only go up through problem 10. After that, don't go any further because we're not going to cover that stuff today. That'll be Tuesday, right? Only do the first 10. Transformations of functions. Oh, and let's review something real quick too. While we're at it, I want you guys just to quickly, I want you to actually, I want to do this. Yeah. Let's graph that linear inequality in two variables. Okay, that was the stuff that you guys went through yesterday, right? So what do we do first? I want you guys to graph it. What are you going to do? Okay, why are you what form are we putting this into? Slope intercept. So we're going to isolate the y. Good. So first thing we would do is we would subtract 2x from both sides. Good. And that gives us 3y is less than, those are not like terms, so I'll just keep them separate. Negative 2x plus 9. Now what?
Divide by 3.
Divide by 3. Okay, so we divide both terms on the right by 3, and we get the result, y by itself is less than, what's the, everybody agree the slope there is going to be an mx plus b form, and the slope is just going to be all this stuff, that's our slope.
Yep.
So we get negative 2/3 x plus 3. Okay. So there's our linear inequality in slope-intercept form. Now let's graph this thing. How would I graph that? What's the value? You guys tell me real quick. What's the value of m?
Negative 2/3.
And what's the value of b?
3.
So how do I graph a function in slope? Graph the boundary line?
Start at 3.
Start at 3, because remember my goal is to make 2 points and connect and extend. So there's a point that I know, right? I know I have a y-intercept at 3, and how am I going to get a second point?
Go down to the right 3.
Rise over run. Good. What's that going to be, Peyton? What's my rise over run tell me to do? That's it. I rise negative 2, so I rise negative 2, and I run positive 3, which means I go to the right by 3. And that gives me another point right there. And I'm going to connect those with my boundary line. Now, is my boundary line going to be dashed or solid? How come it's dashed?
Because it does have an equal sign.
No equal sign. Perfect. Okay, so then we're going to get a dashed boundary line. And finally, am I going to shade above or below the boundary line? Below. And what tells me that is, if y is less than the boundary line, y is the vertical variable. On the y-axis, greater than means above, less than means below, right? So if y is less than mx plus b, I'm going to shade below, like that. Okay?
Another way to tell, I don't know if it's true, but if like the triangle's below the line, then that just be another way to see.
What triangle?
Well, like,
Oh, the slope triangle? No, that's not it.
No?
That has nothing to do with it. No, the part I shade has only to do with the direction of the inequality sign. Okay?
I just wanted to see if
That's a good question. Good question. So we're going to shade, I'm going to make that a different color. We're going to shade that way. And this is what our graph would look like. Good? Okay, so then you guys know how to graph those with the graphing tool? You just make a line, and then there's an option to make, you'll see when you look on that little control panel, there's an option to make your line dashed or solid. And then how do you shade?
Bucket.
Paint bucket. There you go. Okay, good. All right, so that's stuff from yesterday. The stuff for today, transformations. So here's what transformations are about. This is a really helpful tool in math. What it allows us to do is take a really plain, basic function that we're going to call a parent function, the most boring vanilla version of some kind of function, and we can spice it up. We can spice it up by introducing 3 numbers into the function. The 3 numbers are A, H, and K. A is what we call the vertical dilation factor. That's going to be the number that's multiplied by the function out front. We're not going to deal with that one today. That one we're going to deal with Tuesday. The other 2 numbers are H and K. H is the number that we're going to subtract. This is what messes people up. We're going to subtract it from X inside the function. That's the horizontal translation. What does translation mean? To slide something around. So that means we're going to slide the graph, the parent graph, horizontally by a distance of h. And k is the vertical translation, so that's how far we're going to slide our graph vertically. Okay? And k is the number that's added to the function outside of the function. So only those 3 numbers, only 2 of them are we going to deal with today. So let's first of all, let's explore this a little bit. Okay, I'm going to skip down to the, well actually no I won't, I'll do this. We'll start at the top here. So what if I want to add or subtract a number inside the function? Let's use, I got this Desmos file that makes this really easy to see. Okay, so everybody see here I've got the parent graph. P of x equals the absolute value of x. So my parent graph is the most boring, basic absolute value function you could build, which is just the plain old absolute value of x. This is what an absolute value of x looks like. When you graph this using the graphing tool, you're just going to click on the absolute value button, which is the V button. You get this V-shaped function. And to graph your absolute value function, you're just going to have to put one point where the vertex goes and another point on one of the 2 legs, which is either going to bend it up or bend it down. But for today, it always bends up. It's the value of that number A that we're not going to talk about today. That can stretch or compress or even reflect the absolute value graph, but that's not for today. For today, our graphs are always going to have this basic, boring parent graph shape where from the vertex, the slope of the right leg is 1 and the slope of the left leg is -1. So in other words, if I wanted to start at the vertex and get to another point, my rise over my run would always just be 1 to get to a second point. Everybody get that? Okay. Now what happens if I graph a spiced up version of this graph, my parent graph, in which I'm going to subtract h from x inside the function? Okay, well, right now, f of x is identical to p of x because I'm subtracting the number 0. Everybody see that? I have h set to have a value of 0. What if I turn h into like a 2, so I end up with the absolute value of x minus 2? What do you think that's going to do? If I subtract 2 from x inside the absolute value, point the direction you think is going to slide this thing. You'd think to the left, wouldn't you? But it's not. Look what it does. Slides it to the right. Okay? And here's why. Here's why. There's a couple ways you can think about this, and I'm going to tell you both of them, and I think when you connect these dots, it'll make sense. The value of h tells you how far you're sliding this thing horizontally. So if h is a positive number, you're going to the right. But remember, h is the number that is being subtracted from x. So if I have something like the absolute value of x minus 2, the value of h is actually positive 2. Everybody see that? So it's always going to be, the sign of h is always going to be the opposite of whatever that operation is right there. If it's x minus h, then h is positive. What if I wanted to subtract a negative? Like what if I made h negative 3? What's a simplified version of this expression? X minus negative 3. X minus negative 3 is equivalent to x plus 3, right? When we subtract a negative, isn't that just addition? So if I make h negative, I would be subtracting a negative number inside the absolute values, which actually means it would look like the absolute value of h plus 3. Everybody get that? Okay, and it moves it to the left. Okay, so then if I'm adding a number inside the absolute values, or inside the function, could be absolute values, it could be another function, that means I'm moving it left by that much. If I subtract a number inside the function, I'm moving it to the right. And so again, this is a little bit tricky, but you just have to remember that those things are backwards, right? They're the opposite of what you would initially think you were doing. Okay, give me thumbs on that. Does that make sense? Okay, we'll get a little practice with this today too. But now the other thing we're going to do is we're going to add a number or subtract a number outside of the function. So what do you think is going to happen this time if I same thing, I've got my parent graph, and now I'm going to add a number outside, but right now I'm adding 0. What happens if I add 2? What's it going to do to that function? It's going to go up by 2, isn't it? There it is, right? Everybody see that? Okay, and we can see all of those points. Didn't their y coordinates just get increased by 2? Yep. Okay. If I add a negative number, that would be like subtracting, and it's going to go down. Piece of cake. Okay, so f of x plus k outside of the function, I'm going up by k. If I add a negative number, which is the same as subtracting a number outside of the function, I'm translating down by k units. And then what would be going on here if I'm doing both at the same time? Like if I'm subtracting h inside the function, I'm going right by h. And if I add k outside the function, I'm going up by k. All right. So let's practice this. So take that top example. So we're starting with the parent graph, y equals x squared. The most basic, boring version of a quadratic function is just x squared. Well, what if I change it like this? What if I subtract 17 from x inside the part that's being squared, inside the function? What's that doing? Point with your fingers. Which way am I going? I'm subtracting 17 inside the function. Going right. Okay? Make sense? Okay. Now what happens if I start with x squared and I add 9 to the function outside of the function? Going up. Yeah. Okay, now what if I add 21 to x inside the function? I'm going left. Okay. And then finally, what about this bottom case where I'm adding, this time I'm starting with an x cubed graph, who cares? But I'm adding 4 inside that function, and I'm subtracting 2 outside. Excuse me. So I'm going left by 4
And down by 2.
and down by 2. Everybody agree? Okay. All right. So let's try this. Let's try this on one. So this time we want to graph this function. Okay, this is an absolute value function, agreed? I know it's an absolute value function. How come? Well, because look, those are absolute value bars right there, right? Agreed? What was back there? I'm kind of curious. What did I have back there? Oh, never mind. Didn't want to do that. Not now. Okay. That's, well, yeah, that's for later. Okay, so I want you guys to tell me now, first of all, what's the value of k? Negative 6, because that's the number that's being added outside the function. So k is negative 6, and we know that because that's my k right there. What is h?
Negative 5.
No. Positive 5. It's positive 5. because it's the opposite of that symbol right there, isn't it, right? If I've got x minus 5, remember, oops, darn it, I keep doing that. Remember, that actually means I'm getting positive 5, okay? So then which direction is this thing being slid vertically? To the right by 5. So I could take my basic V-shaped absolute value function. The graph's going to have the same shape, but I'm going to take that thing and go right by 5 and down by 6. There it is. Okay? How would I graph this on the assignment? Let's practice one. Ooh, I about hit the end of my day here. I'm starting to not be able to talk very well. Good thing we're almost done. Okay, so let's try. Okay, how about this one? Okay, can you tell me? Well, actually, this is one where we're just picking the graph. So what am I doing to my v this time? I'm going right by 4 and down by 7. Okay, so if we had to pick the right version of that, then that looks like that one, doesn't it? Yeah, well, I kind of gave it away, didn't I? Right 4 and down 7. Okay. Okay, let's try. Okay, I'm going to. Okay, so let's try this one now. So I'm going right 3 and up 7. Okay, so how would we graph that? I'll show you how to graph this. So we're going to click on this thing, right? I think if you want to scoot up, go ahead, but I think that's about the biggest I can get it before it's going to break. So when I'm trying to graph this guy, everybody with me? So I'm going to pick the V tool, right? That's absolute, and if you hover over it, it even says absolute value tool, right? And what's it tell me? I've got to put a point at the vertex and another point. So the vertex started at the origin. Where does it end up if it goes right 3 and up 7? 3, 7, right? It's going to be right there, okay? Well, and then, okay, now that's the vertex. To make an absolute value, the slope is just 1 on the right side, so I would just rise 1 and run 1, and I got it. See what I'm saying? Okay? So that's my absolute value graph, and there it is. Easy enough?
Wait, so it'll do that on both sides?
Yeah, right. All you have to do, the graphing tool knows it has reflective symmetry, so all you have to do is graph a vertex and a point on one side, and it'll automatically reflect that over on the other side.
Not just perfect 1-1 like that.
Okay, but absolute value graphs always will be.
Oh, okay.
Yeah, always will be. Yep. Okay, I am prepared. I think I'm prepared to let you guys work on this. I am. You guys can work. Do the first 10. Work. There is a new one. Yep. Yeah, that's fine.